Hey friends, what's up? This is Saif. In this video, I will be teaching you about different electrical physical quantities. Electrical physical quantities. Here the first one is electric current. The unit for electric current is, which is denoted by I, and its unit is ampere, which is equals to coulomb per second. How can we write its dimensional formula? Generally, we can write its formula as only I, or in terms of charge, we can write like this: Q by T, which is equals to Q T to the power of minus 1. And the next comes voltage, which is denoted by E. The unit of voltage is volt, okay, which is equal to work done per charge, which is given by joule per coulomb. Joule per coulomb. Okay, how can we write? In the previous video, we have discussed the dimensional formula and unit of joule, that is Newton meter. Okay, for Newton, we can write kg meter per second square. See guys, if you don't understand this unit of joule and unit of this formula for joule, that is Newton meter, and formula for Newton, that is kg meter per second square, I have already discussed in my previous video. Please watch previous video to understand this video. Okay, the formula of Newton is kg meter per second square into meter divided by this q. Okay, next, after elaborating this kg meter square per second square into q, now the formula becomes m L square t power minus 2 into q to the power of minus 1. Okay, now the next physical quantity is resistance, which is denoted by R. Its unit is ohm, that is ohm, that is shown by the symbol, and the dimension is voltage by current. For voltage, we can write this dimensional formula m L square t power minus 2 q to the power of minus 1. The dimensional formula for this voltage is this one, and the dimensional formula for current, I can write it as I or q t power minus 1. I will write better q into t to the power of minus 1. This one I have written. And finally, I will write in terms of this charge. Okay, m L square t power minus 1 and q to the power of minus 2. Okay, here this minus 1, if it goes to the numerator, then it becomes minus 1. Okay, it becomes plus 1, and plus 1 minus 2 is minus 1. Okay, q to the power of minus 1. If this q goes towards numerator, then this will also become to the power of minus 1. Q to the power of minus 1 plus q to the power of minus 1 is q to the power of minus 2. And the next comes capacitance. which is denoted by C. Its unit is farad, which is equals to charge per voltage, which is given by Q divided by for voltage mL square t power minus 2 q to the power of minus 1. Finally, I will get m to the power of minus 1 L to the power of minus 2 t square q square. This is the dimensional formula for capacitance. Now next comes inductance, which is given by L. Its unit is Henry. The formula for this inductance is EMF by di by dt. See my dear, to understand this one you need to remember the definition of inductance, that is definition. It is the ratio of potential difference to the time rate of change of electric current. Here it is the ratio of potential difference, this is potential difference, to the ratio to the time rate of change of current with respect to time, which is given in the definition, to the time rate of change of electric current. Okay, now how to derive its formula? We can directly write the formula for this voltage, that is mL square t power minus 2 q to the power of minus 1 divided by di by dt. Can I write like this? For di, change in current, I can write qt to the power of minus 1, right? For time I can write direct t. Finally, by solving this I will get mL square q to the power of minus 2. The definition of this capacitance is when 1 coulomb of electricity changes the potential between the plates by 1 volt. So we can write this C by V. So better I will write the definition of capacitance here. Capacitance definition. I don't have space here, so I will write here so that you can derive the formula easily by remembering this definition. Definition is when 1 coulomb of electricity changes the potential between the plates by 1 volt. That is what here it is written, C by V. For capacitance, 1 coulomb of electricity is C, changes the potential between the plate by 1 volt. So in the denominator I have taken V. Okay, now let us see the next physical quantity, it is electric conductivity. Next one is electric conductivity. Electric conductivity. The unit of electric conductivity is Siemens per meter. Siemens is nothing but inverse of ohm. It is inverse of ohm. Okay. The unit which is also equal to mho, mho. How to derive its formula? First, we have to take the inverse of resistance. Inverse of resistance, that is ml square t power minus 1 q to the power minus 2, right? This is the inverse of resistance divided by, this is meter. For meter I will take L. By solving this I will get ml, because this L cancels with 1L, ml t power minus 1 q to the power of minus 2. Okay. The next comes charge density. Charge density. What is charge density? It is denoted by small r. Let me tell you this definition of this charge density. It is the measure of how much electric charge is accumulated in particular field, in a particular field. Okay. It may be charge density per unit volume or surface area or length. If it is per unit length, it is given by charge per length. It is a measure of electric charge per unit length, that is given by q into L to the power of minus 1. If it is per unit surface, then it is given by C by A q into L square L to the power of minus 2. If it is per unit volume, it is given by q L to the power of minus 3. Understood? Now we'll see the next property, that is magnetic field. Ninth one, that is magnetic field. This is magnetic field. Generally we can write like this for magnetic field. It is Lorentz force. Lorentz force is equal to, that is F, charge into magnetic field, that is B, this is B, into velocity. This page is over, let me write in the next page. Into velocity, it is, no, can I write like this? Magnetic field is equal to Lorentz force, that is F, divided by charge into velocity. Charge into velocity. For Lorentz force, I can write the dimensional formula for force, that is ml t power minus 2, which we have discussed in previous two videos, that is mechanical physical quantities part 1 and part 2. In that I have derived this ml t power minus 2 as the formula of force. Okay, charge, which is generally given by q, into velocity is L by t. For that I can write as m t power minus 1 q to the power of minus 1. Okay, in terms of charge. And next comes magnetic flux, that is 10th one, magnetic flux. Magnetic flux, which is given by phi s magnetic flux. Let me write the definition of magnetic flux, that is, it is the number of magnetic field lines passing through a given closed surface. It is given by phi b is equals to b into a into cos theta, where b is nothing but magnetic field, which we have derived here. This is magnetic field, and a is surface area, and theta is angle between the magnetic field and normal to the surface. Okay friends, let me wind up this video here. I will derive its dimensional formula in the next video. Thank you.